What is up? It's your boy, the Knologist. We're back with another episode of programming study sessions. So, code study session and OSRS AFK training. Yeah, I'm gonna be about 59 wood cutting right now. I need 3 more levels. Then I might do construction too, just because it'll be fast. And then I'll do some quests, like because I know people are dying for quest content. But as you guys know, there's not a lot of quests left. I'm actually getting pretty close to completing all of them. So you got enums. Here's one of the things it can do that I often miss in Go. Sending channel. Oh, okay, so it'll be these types. Let's look at the union type here. TypeScript system allows you to build new types out of existing ones. So now print ID is now number string. They can accidentally pass. A developer calls send, they can't accidentally pass an invalid sending channel like Slack or even a misspelled ML. The TypeScript compiler will catch that mistake at compile time. In Go, we don't have these nice things. We embrace the grug mentality. What is grug? The grug brain developer. Layman's guide to thinking like the self-aware, small-brained. Well, eternal enemy, complexity. Complexity bad. Yeah, we don't want to be grugs. We want... Complexity is something that is there for a reason, right? Like... It shouldn't be your aim to avoid complexity. It should be your aim to make your program as simple as possible. If as simple as possible means like there's a lot of complexity to it, then that's just what it has to have, right? That's not because we're trying to do things a certain way. We're trying to do things in the way that's correct. That's basically our job as a dev. Okay, so type. So we can use enums instead, I guess. Closest thing we have to union type is a type definition. Type sending channel string, const, email, SMS, phone. So we can simulate multiple types by using some sort of enum strategy. Email sending channel email, SMS sending channel SMS. So we're basically saying this represents these different things. Okay, so email, SMS, phone, and then function. And then function, send the message. Okay. It's a bit safer than using the plain old string in Go, but not completely safe. Go will stop us from doing this. String is not sending channel. But it will not stop us from doing this. Okay. Slack is automatically implied as a sending channel. Will also not stop us from doing this. The sending channel is just a wrapper for string. Because we made some constants of that type, most developers will just use those constants. We made it easy to do the right thing. That said, Go still doesn't force us to do the right thing like TypeScript does. Okay, cool. I'm still not 100% clear on that. Use the following code to answer the questions. Check permission. Well, check permission perm user. This is technically allowed because it's wrapped in perm. It'll throw it for admin. The rest of them follow the type structure. And this one wraps perm user. So it wraps the user string in perm. So it treats it like it's one of these. I completely forgot about that. Type definitions, it makes your code a bit safer. Okay, cool. Const. Let's break it down line by line. Sending channel string. This defines the new type. I don't get it. So code, so we're defining a new type here. It's essentially saying I'm creating a new type that is underneath the hood a string. Okay, cool. It's known as the type definition. Cool, cool, cool. It has its own distinct type. This helps with type safety. And then const. Values that cannot be changed once they're declared. Email. Oh, because it's already of type string. We're saying email of type sending channel equals email. Okay. Each constant is given. Explicitly given the type. Type sending channel. They're Stein string values that correspond to their names. By defining these type constants, we create a set of predefined valid options for the sending channel. This is a common idiom to create something akin to an enum. Okay, so we're simulating an enum kind of thing. We're kind of modeling an enum. Send notification channel message string. This line defines a function named send notification. It takes two parameters. The channel, this is our custom channel sending type. This is the crucial part that enforces a bit of type safety. When you call this function, the argument you pass for ch must be of the sending type. Okay. Message, this is a regular string. Because ch of type is sending channel, the Go compiler will prevent you from accidentally passing a plain string that isn't explicitly converted. Oh, okay. Now I get it. So I'm going to share on the screen real quick why this works, and then in summary. So basically, let me share this. So basically we create our type, and then we say that we want to explicitly define the types that are in here. So basically this, email, SMS, and phone, because we don't want to explicitly pass strings. So the sending channel, we could technically just skip this whole thing and pass a string, but we want to explicitly define it using these const values. So CH is type sending channel. Sending channel has 3 constant values associated with it: email, SMS, and phone. And that way we don't pass a string in there, and that prevents errors, misspellings, and things like that. We're creating a constant, so that way it throws an error if this doesn't work out. So here is where you can pass a plain string in this message, but you can't pass a plain string in this channel. So models the behavior in enum and prevents the passing of a plain string. Perfect. And that's kind of how it works. In summary, this pattern defines a specific, cleaner, safer. Okay, so but to prevent using a plain string that could result in errors, we use this pseudo enum setup to prevent this. You've grasped the core concept. You're absolutely right. We are defining what specific channels are acceptable by using type sending channel string, and then defining the constants email, SMS, phone of that specific type. We create a pseudo enum. This makes it much harder to accidentally pass a misspelled or invalid string like Slack, email, to our send notification function without the Go compiler flagging it as an error. It's all about making code more robust, more readable. So this is basically an error check kind of thing. But yeah, we're at, let's see, we got about 5 minutes. We'll check perm admin raise an error from the compiler. Perm admin. Perm admin? No, because you're wrapping it in perm. IOTA. We'll continue this one in the next. Actually, no, we could just do this because this is, I think, the last. Is this the last lesson? Yeah, it is. Okay, let's just make this one an extra long episode then. And then just do it that way. IOTA. language feature that, when used with a type definition, and if you squint really hard, looks like an enum, but it's not. What? It's called iota. When used with a type definition, and if you squint really hard, it looks like an enum. Well, but it's not. It's called iota, okay? This is probably some sort of special keyword in the Golang. There's a special keyword that creates a sequence of numbers, starts at 0, and increments by 1 for each constant. I guess that's kind of like an enum, because it naturally increments itself. Oh, so it's like a numeric. Instead of doing a channel type, you do a numeric. So this is technically an enum. In C and C++, they have enums where you could actually just use a numeric. Well, in C++ they do. I don't know about C. Gotta add this to my notes. Type sending channel int. Oh, another bird's nest. This game is very like audio as well. That's why JAD is like one of those things that you have to use all senses to kind of do. Special keyword in Go that creates a sequence of numbers. It starts at 0 and increments by 1 each time in the const block. Okay, so you're basically creating an enum with numbers instead of those strings. Sending channel equals iota. and then SMS. Phone. Much like you would with an enum, but remember it's not an enum, it's just a sequence of numbers. Yes. Okay, so now we just have to define a iota basically. One sec, let me cut this shit down. I can do that. Actually, let's get a bird's nest. Here I thought it would have been a way longer thing. Examine. Okay, so main. Now we got to create our own thing. Define an email status type that uses an iota syntax. Email status type. So basically, but then I want to create an iota. So basically, I go const. And I want to simulate an enum. So basically, what I'm doing is this. I'm just going to share again. Basically, this is what's happening here. You create your type here of sending channel, and then you assign that type to an iota. Iota defaults to 0. Iota defaults to 0, and then the rest of the values go 1 and then 2. In sequence, going down. This increases for every item in const. So basically what we're going to do is the same thing here. So we're going to do type string, and then we're going to go const. Email bounced. Give it the type email status, and then equals iota. Now we just name the rest. Email invalid. Email delivered. Email opened. Sending channel, email status. Make sure I spelled everything correctly. unexpected new line in Go declaration. An email status type. Do I need to define what else? Type sending channel int. Type email status string. Email status type that uses the following states. Let's try that. Const email status equals email equals sending channel iota equals iota. Oh, does that have to be capital? Let me try that. Let's try this. Your underline status bool, but the integer is 1 or 2. You can't assign it to an int. Oh, does it have to be int? Is that why? Oh, because it's not an enum, it's an int. Okay, there we go. That's why they say it's an enum. It's not an enum. It acts like an enum, but it's not. There we go. So let's go back to the notes real quick and I'll explain what just happened here. Sending channel int. Iota acts as an int. So that means everything else will be assigned an integer value. So like, I'll show you guys again. So equals 0. Technically this is equals 1. Iota is of type int, and that's what happens. This is what's happening under the hood. So that is how you use iotas. It acts like an enum, but it's technically not an enum. So if that makes sense, we're good to go. So we can submit this. It's correct. And we're done. So the last one is this quiz, I guess. And then there's, I guess, 4 questions. We'll do that in the next episode.